Hi Rockridge, welcome back to Algebra 2. Today we're talking about quadratic functions, and specifically we're going to graph quadratics, we're going to graph parabolas off of standard and intercept form of the equations. So let's look and see what we mean by that. We've been using vertex form. We've been using y equals a times x minus h squared plus k. We've been using vertex form. Today we're going to see standard form and intercept form. Let's think about how we graph using vertex form. Remember, we use vertex form to use the vertex, right? We pulled the vertex off, the vertex being the middle point of the parabola, the min or the max of the parabola, and we found the vertex at h, k. That's the form we were given, and that's the vertex that we pull off directly. Sometimes, though, we're not presented the parabola or the quadratic in this form. Sometimes we're given the quadratic in standard form. Y equals ax squared plus bx plus c. Sometimes we see it in this form. A number here, a number here, a number here. This is not vertex form. We can't pull the vertex off directly like we used to. We can find some interesting information though. We find the y-intercept, or where this parabola crosses the y-axis, in much the same way that we find the y-intercept for a line. Remember, for a line, y equal mx plus b, that constant b is where it crossed the y-axis. Well, this time, the constant c is where the parabola crosses the y-axis. So this parabola crosses at 0, c. So whatever c happens to be, that's going to be the y-intercept of your parabola if you're given standard form. The vertex is a little trickier to find, but we have a little formula that we memorize to find the vertex using standard form. The vertex is found, the x value of the vertex is found at negative b over 2a. So go ahead and commit that to memory over the next few days. Negative b over 2a. Negative b divided by 2 times a is the x value of the vertex. To find the y value of the vertex, you just plug the x value in here and find out what y is. So basically you plug in the x into the function. So f of negative b over 2a is the y value of the vertex. And you'll get some practice on that. Intercept form looks even different. Intercept form looks like this. Y equals a times x minus p times x minus q. These factors here help you find the intercepts. When we were doing all of our factoring work and we got down to something that looked like this, factored form of a quadratic, we used these to find where it crosses the x-axis, the intercepts on the x-axis. So the x-intercepts come straight off of intercept form, and they're found at p, 0, x minus p set equal to 0 and solved, and q, 0, x minus q set equal to 0 and solved. So that's two pieces of information that are easily pulled out of intercept form. Now the vertex on this, if you think about it, the vertex is found smack dab in the middle of the two x-intercepts. So if you were to take p plus q divided by 2, or the average of p and q, the middle of p and q, you'd have the x value of the vertex. And then similarly for standard form, we just take that x value and plug it into the original to find the y value of the vertex. So it's just f of p plus q over 2. So let's get into some examples here. Again, let's remind ourselves what standard form looks like. Y equals ax squared plus bx plus c. And let's remind ourselves of finding the vertex using the formula negative b over 2a. The steps to graphing these using standard form are to first find the vertex using our formula, graph the axis of symmetry, pick another point to evaluate and plot it, plot zeros using our calculator, and then reflecting points through the axis of symmetry. So let's take a look at our first example here. y equals negative x squared minus 2x plus 8. I see that this is in standard form. I'm going to make a note to myself of what a, b, and c are. A is negative 1, b is negative 2, and c is 8. So to find my vertex, let's first find the x coordinate of my vertex. It's negative b over 2a, which for this one is negative 2, or positive 2, over 2 times negative 1. That comes out to be negative 1. That's the x coordinate of the vertex. To find the y coordinate, I plug this negative 1 in for x up here, and it'll spit out y for me. So y equals negative 1 squared minus 2 times negative 1 plus 8. I'm just plugging negative 1 in for x. This spits out a y value of 9. So now I've got a vertex at negative 1, 9. Negative 1, 9. My axis of symmetry goes right straight through this middle here. So my axis of symmetry is the invisible line x equal negative 1. I'm an upside down parabola, so I graph like this. I go ahead and look and see if I've got a minimum or a maximum. I look for my extrema. I don't have a min because I'm an upside down parabola. I do have a max, and that's at a value of 9. So my minimum doesn't exist. My max is a value of 9, and I found that off my vertex, at my vertex of negative 1, 9. My max is 9. My domain of this and every parabola is all real numbers. Range, since this is an upside down parabola, I scan bottom to top, and I go from negative infinity, and I top out at 9, so that's my range. My zeros, I can go ahead and take a look at my calculator. I can plug in y equal negative x squared minus 2x plus 8. I can graph that. I am confirmed that I have my upside down parabola. And I can look for my intercepts. I go second, trace. I want to find my zeros, choice 2. And remember, I always go to the left of the 0 I'm looking at and then to the right of the 0. So I'll scan my parabola and pick a point on the parabola to the left of the intercept I'm looking at. Enter, and then to the right of the intercept. Anywhere's fine. That's good. And enter, and then enter again. This is saying I have a 0 at negative 4. So I go ahead and jot down my first 0, or my first x-intercept, is at negative 4. Now let me look at my other intercept. Second, trace, zeros, and I'll get a little closer to the other one I'm looking at. It looks like it's going through 2, but I don't want to assume. Enter, and then I'll go a little to the right. Enter, enter again, and sure enough I've confirmed that there is a 0 or an x-intercept at positive 2. So positive 2. My y-intercept can easily be found off of this form right here. It's equal to this c. So 0, c, or 0, 8 is my y-intercept. 0, 8. All right, so that's how we do those. Let's do one more like that. Let's first identify A, B, and C. A, for example 2, is 2, B is negative 8, and C is 6. So let's first find the x-coordinate of our vertex by saying negative b over 2a. That's my x-coordinate. Negative b, negative 8 is positive 8 over 2 times 2. So that's a positive 2. 8 divided by 4 is 2. So the x-coordinate of my vertex is 2. Let's do y now. Let's plug 2 into the original. So 2 times 2 squared minus 8 times 2 plus 6. When I simplify all of that down, I should have a negative 2. So negative 2 is the y-coordinate of the vertex. Let's go ahead and draw that. 2, negative 2. So my vertex is here, and looking at my original, I see that my original has a positive leading coefficient, so I am an upward facing. So that's a little mini beginning of the sketch of my parabola here. I haven't quite drawn the exact parabola, I'm just sort of getting myself in the map here. An axis of symmetry cuts it straight down the middle, so the axis of symmetry is the invisible line x equals 2. Extrema, min max. My min, I do have a min, it bottoms out here at negative 2. I don't have a max, it goes on forever. My domain, like all parabolas, like all quadratics, is all real numbers. My range, bottom to top, is negative 2 to positive infinity. And I'll go check my calculator for the zeros. So let's go ahead and in our calculator, go ahead and graph our new one. 2x squared minus 8x plus 6. Graph it just to take a look and make sure I'm on the right track. Yep, looks like the one I started to sketch. Now, second, trace, zeros. The first one I want to go after is this one, and this point is to the left, so I'm good there. Enter. And then I'll pick a point to the right of the 0 that I want to calculate. Enter. And enter again. This says my first 0 is at 1, 1 comma 0. So I'll go ahead and jot that down. 1 is the first 0. The second 0, I'll go ahead and do the same steps. Second, trace, 0. Let me go a little bit closer to it. Get a little closer here. That looks good. So I'm to the left, enter. And now I'm to the right of the 0. Enter, enter. This says the other 0 is found at 3 comma 0. So I'll jot that down. Those are my zeros, or my x-intercepts. Now my y-intercept is one of the easiest things to find for standard form. That's just equal to my c. So 0 comma 6 is my y-intercept. So it'll be 1, 2, 3, 4, 5, 6 is my y-intercept. And I said I had zeros at 1 and 3. 1 and 3. And I could possibly reflect this point across the axis here to graph it so that I can fill out my graph a little better. So we'll want you to use this whole table of information to graph these. And we could actually go back to number 1 and make that a little prettier too, right? Because now that we have zeros of negative 1, 2, 3, 4 and positive 2, we could clean that one up as well. And we said our intercept was at 8, which we've already graphed here. So all of this information that you found algebraically helps out with your graphing. Let's finalize our y-intercept at 0 comma 6. Alright, so that's how we use our algebra in standard form. Now let's remind ourselves about intercept form. Intercept form looks like this: y equals a times x minus p times x minus q. It's basically factored form. The first thing we do is we use these intercepts that we're given. We use the intercepts from the equation x equal p, x equal q. We average those to find the vertex. So p plus q divided by 2, that's your x-coordinate of your vertex. And then you plug that in to find the y-coordinate of your vertex. We graph that axis of symmetry and we draw our graph. So these are kind of fun. Let's take a look at the first one here. We have y equal x plus 6 and x plus 2. We can immediately identify that this is given to us in intercept form. It's nice and factored form here. So we know it's intercept form. And we immediately pull off intercepts of x equal negative 6 and x equal negative 2. We immediately see that it's crossing at negative 2 and negative 3, 4, 5, 6. That's the great thing about intercept form. That's what we can find immediately. The other things that can quickly be determined are the middle, or the vertex. So if we were to average these two together and find the middle, we would find the vertex. So negative 6 plus negative 2 divided by 2, or negative 8 divided by 2. Negative 4, that's the middle of this. So this cuts it in half here. If I want to find the y-coordinate of the vertex, I take this, oops, sorry, that's a negative 4. Negative 4. If I want to find the y-coordinate of the vertex, I take this negative 4 and plug it back into the original. I say y equals negative 4 plus 6 times negative 4 plus 2. So that's 2 times negative 2, that's negative 4. So negative 4 is the vertex of my parabola. Negative 4, negative 1, 2, 3, 4. That's the vertex. And I can clearly see that I'm going to look like this. Let's take a look. Axis of symmetry, that's this little line that cut us in half. That's x equals negative 4. Min max, I have a min, not a max. A min of negative 4. No max. Domain, like I always have, of all real numbers. Range bottoms out at negative 4 and tops out at infinity. Zeros, I've already determined that. I got those straight away. Zeros of negative 6 and negative 2 were immediately determined. Now my y-intercept. How would I find my y-intercept? That's where the graph crosses the y-axis. I can either set y equal to 0 and solve. I'm sorry, set x equal to 0 and solve, or I can use my calculator. This one's pretty easy to do by hand. If I was to set x equal to 0, that's what a y-intercept is, right? That's when x equals 0. If I were to set x equal to 0, what would I get for y? 0 plus 6 times 0 plus 2. This is to find my y-intercept. That's the work that we're doing now. That's just 6 times 2. That's 12. That was pretty easy to do. You can certainly use your calculator to check, or if you don't feel comfortable with this method, but I would definitely encourage you to set x equal to 0 on these intercept forms. So 0, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's probably up here somewhere. And I can reflect that point across this axis of symmetry. Drag this up here. I can reflect that over here because these are symmetric, right? That's what the axis of symmetry does. It cuts it in half perfectly. So if you wanted to extend this using all this new information that you've calculated, you can. So that's what our parabola looks like using the algebra, using intercept form. Now let's look at example number 4. Example number 4 again is in intercept form. It's in factored form. We'll go ahead and find our x-intercepts first, right? Let's go ahead and look at our x-intercepts. Where does it cross the x-axis? Well, we set x minus 3 equal to 0, so x equal 3 is one of them. And x equal negative 2 is another. So positive 3 and negative 2 are intercepts. I can go ahead and fill that in on my table. Positive 3 and negative 2. To find my vertex, I need to get in the middle of this, the middle between these 2 points. That's where the vertex is. So I need to take the average, 3 plus negative 2 divided by 2. That turns out to be positive 1/2. So I have an x value of positive 1/2. Not terribly pretty. I don't love fractions. I'm going to love them even a little bit less when I start plugging in 1/2 for x to get the y coordinate of the vertex. So the y coordinate of the vertex is, let's clean this up a little, sorry, is negative 1/2 times 1/2 minus 3 times 1/2 plus 2. Not the greatest, but we can do this. We have fraction savvy. So it's negative 1/2 times negative 2.5, or negative 5/2, times positive 2.5, or positive 5/2. All that to say that we have a positive 25/8 as a y coordinate. Again, not gorgeous, not beautiful, but we've found that vertex. So let's kind of estimate here 1/2 and positive 25.5. I'm sorry, 25/8. So 1, 2, 3, 1, 2, 3 and 1/8. It's kind of there, I guess. It looks pretty good. That's the center. And that certainly indicates that I'm an upside down parabola, which I was expecting anyway because it had a negative leading coefficient. So I'll go ahead and draw that in. It's not gorgeous. I'll clean that up a little bit. So that's what our parabola looks like. Our vertex is at 1/2, 25/8. Our axis of symmetry cuts it straight down the middle here, straight through x equals 1/2. Our min, we don't have one, we're upside down. Our max, we have at 25/8. That's where it tops out, or 3.125 if I've asked for decimals. Domain, like all of them, all real numbers. Range, bottom to top, negative infinity, up to that 25/8. We've talked about our zeros already. Our y-intercept, again, so easy to find. We just set x equal to 0 and solve. So let's do that in pink. So y equals 1/2 times, set 0 for x, 0 minus 3 and 0 plus 2. 1/2 times, let's see, negative 3 times positive 2, that's times negative 6. So negative 3, oops, did I miss a negative? Yes, I did. This was a negative here. Sorry about that. So that's a positive 3. That makes more sense. Check for reasonability here. So you must cross at 1, 2, 3. And I could even reflect that over this way. Go 1/2 and go over here like this to smooth this out a little. So my y-intercept is at 0, 3. All right. So we use all of that algebraic information to graph nice, clean, full, complete elements of our graph of our parabola. Let's convert algebraically between the forms. Let's start first by converting from factored form here, intercept form, into standard form. So our goal is to convert into standard form. And again, that's y equal ax squared plus bx plus c. That's what we're after here. And so to get there from here, we need to FOIL. We just need to multiply both of these. We need to distribute. So y equals x squared plus 2x plus 6x plus 12, or y equals x squared plus 8x plus 12. So now I have this in standard form. I was also asked to find the y-intercept, which is so easy with standard form. The y-intercept is just at c. So the y-intercept is at 0, 12. So easy once you have everything in standard form. Let's take a look at B. A little bit more work here to get us into standard form, but similar steps. Y equals 1/2, and this x plus 4 squared is actually this, right? X plus 4 times x plus 4. And don't forget about this negative 5 hanging out there. So we were given vertex form, and we need to find standard form. Here we were given intercept form, and we need to find standard form. So continue with this work. Boil this together, x squared plus 8x plus 16 minus 5. We have a 1/2 hanging out here, so y equals 1/2 x squared plus 4x plus 8 minus 5. And so finally, y equals 1/2 x squared plus 4x plus 3. So that's our standard form, and now we can yank that y-intercept right off there. The y-intercept is found at, right here, 0, 3. All right, so we converted two forms back into standard form. Let's see what we're asked for in example 6. Convert everything into intercept form. So it sounds like we need to do some factoring. To get to intercept form, we need to do some factoring. So let's see here. We are in standard form, and we must get to factoring into intercept form. So what are factors of 6 whose sum is 5? Let's see. Multiplies to 6, adds to 5. 2 and 3 get us there. So factored form is x plus 2 and x plus 3. That is intercept form. And then we're asked to determine the zeros, which intercept form is great for determining zeros. It's just each factor set equal to 0 and solved. So our zeros are at -2 and -3. B, we need to get to intercept form. Let's first get ourselves into standard form, because once we get to standard form, we can factor it. Right now, we can't factor this. So let's go ahead and combine these. Y equals 2 times x plus 1 times x plus 1 minus 8. Y equals 2 times x squared plus 2x plus 1 minus 8. Let's keep distributing. Y equals 2x squared plus 4x plus 2 minus 8. And then we have y equals 2x squared plus 4x minus 6. Now let's get this into factored form so that we can get this into intercept form. So I see here a greatest common factor of 2. 2 times x squared plus 2x minus 3. Let's see, what multiplies to -3 and adds to 2? If I did, let's see, 3 and 1, and let's make the 3 positive and the 1 negative. And of course we have this 2 out here. So let's see, the zeros must be, so this is our intercept form. This is what we were after, intercept form. The zeros must be found at -3 and +1, which is so easy to do once we're in intercept form. All right, let's do one more set of converting. Converting into vertex form, our friend HK format. So let's go ahead and see how we can get there. Now, y equals x plus 2 and x minus 4. We need to get to vertex form. So let's see. Y equals x squared minus 4x plus 2x minus 8. Or x squared minus 2x minus 8. So this is what it is in standard form. We need to get this into vertex form. So what is the vertex of this? Remember what the skeleton of vertex form is. It's y equals x minus h squared plus k, right? So we need something to fill in here and something to fill in here. And so we need to get this into this form. If we were to look at this, we might use completing the square to figure this out. Remember completing the square? So if we were to, because that's basically what we need here, is to complete the square. So if we were to yank this -8 out here and stick it outside the parentheses, what would we put in here to complete this square? Half of -2 squared is +1. And whatever you do in here, you have to cancel out here. So you can convert this into x minus 1 squared, and then you have this combined as a -9. So there's your vertex form. If you thought of this in a different way, if you said, wait a second, these are the intercepts, if I was just to average them together, 2 plus -4 divided by 2, my x-coordinate of my vertex has got to be +1, right? +1. That's my x-coordinate of my vertex. So I could go to my vertex form and say, well, that must mean that this number is 1. How do we find our y-coordinate? We plug this into the original. So 1 plus 2 times 1 minus 4, that's 3, times -3, which is -9, so that's where I would put this in for k. So there's a couple of different ways you can go about getting from intercept form into vertex form. You can complete the square like we did here, or you can average those intercepts to find the vertex and plug it into the form we already know. Let's see, the last thing we were asked here was to determine the vertex. Well, obviously, once we have it in vertex form, we can quickly pull the vertex off as 1, -9, which we calculated here. Okay, so a couple of different ways you can go about that. Now, B, let's take a look at B. We have standard form, and we need to get to vertex form. We definitely would do ourselves a favor by completing the square on this one. So let's complete the square, pulling this -5 out here. I see a common factor that I need to get out of my way. And what do I need to complete this square? Half of, let's -5. Half of 2 squared. Half of 2 is 1. 1 squared is 1. Whatever I do out here, 3 times 1, I have to balance out here. So now I have y equals 3 times, this perfect square is x plus 1 squared, and then -5 and -3 is -8. So there's my vertex form on that. That was definitely useful to use completing the square to get into vertex form there. Now, clearly vertex form spits out our vertex nice and clean. Our vertex on this, of course, is -1, -8. Easy peasy. All right? All right, that was a lot. Take a little bit of a break and go ahead and try your independent practice number 37, and let me know if you have questions.